So hello and welcome back to another video. This time we're going to talk about the R principles in eco-design for medical technology. I'm Lucas Benegonda, and we have helped over 30 MedTech companies to be more sustainable with plastics. Let's just get right into the topic. So the R principles are a collection of heuristics, I would say, that when applied correctly are able to reduce your environmental footprint and your cost significantly. And it is a framework that you can run your device through in the beginning of your development, and you can just extract so much value from that. So number one is you start with refuse. So ask yourself, what would be the best alternative to making this happen? You usually do screw over your current business model by doing that, and that is why people don't like to do it. But imagine the following example. You are selling injections for diabetes. So you have an insulin pen or something like that you're selling. So imagine what would happen if a person wouldn't even need insulin. So what you would do then is either help them not get diabetes, so help them stay healthy, or you could find a replacement for insulin therapy. So instead of you're using a pen every day to injecting you with insulin, you could monitor the blood glucose. And sometimes with dietary habits, you could go around the insulin injections. So refuse, avoid the impact or cost altogether in the first place. Or another example would be you have 5 packaging steps and you just eliminate 1 or 2 of them. And then you just have 3 packaging layers, and in the end, you're still sterile and you're saving a lot of cost and impact. Then rethink. Reconsider the product or your business model in a way to reduce the impact. So fundamental differences in concept. I would say a good rethink approach would be you have this impression materials that you use to get an impression of your teeth. So you have silicone in your mouth, you bite down. And for those of you who had braces, know what I'm talking about. What you could also do is just make a 3D scan, and with that, rethink how you're doing the procedure. So here is a lot of innovation going on in the 0th R, and in the first R, there is a lot of innovation going on. That's why I really like them. And then the next one is reduce. And here people usually start. So usually they skip to point 2 because rethinking and refusing is just too difficult. But I implore you that you do this. Do the R0 and R1 first. Then reduce. You minimize the material use, you optimize the design for less impact. So far, so good. You reduce wall thickness, you optimize. You can also use a bunch of simulation tools to help you do that. So very nice. Then reuse. You try to design your product for multiple uses with the same purpose without reprocessing. In MedTech, that is quite difficult to achieve because if you have a surgical device, you at least need to sterilize it in order to use it again for your application. And then a bunch of problems come in, such as logistics and convenience and stuff like that. So really think about how your reuse scenario will impact the workflow in a hospital, for example, or the workflow of a patient when it's a self-use device. But reuse can be a very nice tool in your belt to make your impact and cost per functional unit, as they would call it in an LCA, better. Then repair. You can always fix defects and extend the product lifetime without replacing parts. That is, you would maintain something like a ventilator in the hospital, and with that, save it to be wasted. And then we come to refurbishment. So if we take back old devices, we refurbish them to as good as new working conditions and resell it to other countries or also other facilities. That is what refurbishing means. And then we come to a remanufacturing. And it is very important to distinguish reuse and remanufacturing, because reuse means like we reprocess as a hospital certain surgical devices, like scalpels and stuff like that. We're just putting it through the sterilization unit and we are reusing that. But a remanufacturing would be such a case when you have a catheter that you used once, they get collected, certain companies wash them, clean them, maybe sometimes repair them, test them, and become the manufacturer, the legal manufacturer of that medical device, no matter what's printed on there. So you may have like original parts or original device manufacturer that brought the device on the market the first time, and then it gets used in the hospital, gets picked up by another company, reprocessed, and they are now the legal manufacturer of this medical device. That is what remanufacturing would be. So you rebuild the product in a like new condition, and they have all the liability and not the original supplier, the original manufacturer. And then we come to repurpose. You could use it in a different context. For medical device, I do not have a very good application with that. So maybe you could use old scalpels for whatever, like in another context. When you use scissors or scalpels in another context to just manufacture it in a manufacturing context or stuff like that. That was a surgical device before. I don't know if you want to do that. So for repurposing, I do not have a very good example, to be honest. And then recycle. So this is where everybody just jumps to immediately. I said you're going to jump from 0 to 2 directly. So to reduce, this is where everybody starts that has a little more experience, but everybody else just jumps to 8 straight away to number 8. So everybody just talks about recycling, but every other step needs to come before we start with recycling, because it's better to avoid the waste in the first place, to reduce the waste, to reuse what is reusable, to remanufacture what is remanufacturable, and then go to recycling. Before we just think, yeah, we're just going to keep everything the same, but now we're going to recycle. It's actually better to go through it in order. So what you do with recycling, you understand what that means. Break down materials into feedstock, may that be in mechanical, solvent-based, or chemical recycling for new products. And these products do not need to be the same products, but can be the same products. And then in the end, there is recover. So if there is nothing you can do left with a plastic waste, you can still burn it. And people are trashing recovery. I do have in another module I made, I have other steps to waste management on there. And that will be incineration without energy recovery. And that's clearly worse because at least you get some energy for the CO2 you're emitting. And then there's landfill. Which is, in my opinion, worse because you use a lot of land and you potentially contaminate stuff. If done right, controlled landfill can be an option. However, then there is also uncontrolled landfill or uncontrolled burning, which means like it's probably not a good idea for medical waste to end up in rivers and in the ocean and stuff like that. So energy recovery gets a bad rap, but it's at least you get energy back. And not to trigger too many green electricity advocates, but green electricity has its issues. Like wind and solar energy has the issue of being fluctuating. So if you have a lot of wind, you have a lot of sun outside, it's good. You have a lot of power, you have a lot of energy. You need to store it somewhere. That's where the difficulties come in. And then if you do not have the storage, then you do not have power. And there is where you can use waste incineration and waste energy recovery to basically smoothen out the power curve. Because like you can choose to burn more waste. but you cannot choose to have more sun or choose to have more wind. That's like not regulatable. Okay, so I'm going to tell you my paradigm for using the R principles. So you should always go from top to bottom. Do not skip steps. Really consider them. Go from top to bottom. Never pick the easy route. That would be like synonymous with going from top to bottom. So just do not say, yeah, we need to do recycling because we need to keep our business model intact. Like, be radical, be radical. I mean, you don't have to like throw overboard your whole business model. Just make a small experiment on a new business model and test if it works. You don't have to stop everything you're doing and just change over everything, because that would be also a lot of risk. But if you're using single-use devices, why not bring one multi-use device to market and see if there are advantages, disadvantages, or learnings that you can take from there. Then frame it as cost, ecology, and patient outcome. The R principles were invented for environmental footprint. However, you can do the same thing for cost. It is exactly the same thing. Cost and environmental footprint savings are not diametrically opposed to each other. They usually very well correlate with each other. Reducing the material that you're using or avoiding to do something, that are like prime cost saving examples. And you save cost and environmental footprint, and that is just perfect to get these things approved. And then in the end, think also about the patient and the hospitals and the staff that has to use your device. Because if you have a single-use device, and I do not want to get into multi-use versus single-use, we're going to do that in another video. You have to think about who is going to do all that work. So if you say like, okay, yeah, we can now disassemble everything and we can now reprocess that in the hospital. Hospital needs to first have the reprocessing facility. And if the patient outcome would be worse, if you're remanufacturing a catheter, for example, that wouldn't be good either. So you have to think about the patient outcome too. And do not only drive out cost, but ecological footprint, but also cost, because cost is better patient outcome immediately. Like if your patients do not have to pay as much for your medical procedure, that's good. That's good. Healthcare spending is through the roof everywhere around the world. So if you can drive out costs, that is also sustainable. Then you should improve the patient and user experience, as I just laid out. And remember that these are principles, are heuristics. There are rules of thumb. They are not inherent laws of nature. So you need to calculate your improvements in cost and in environmental footprint continuously. So do an LCA, even if it's just like a very low tech one. Really calculate your environmental footprint, because sometimes remanufacturing doesn't make sense from a cost and environmental footprint perspective. Like it makes sense to remanufacture a ventilator, very big device, very big impact, very big cost. But a syringe, there's no way in hell you can make that worth the environmental footprint and also the cost you're putting in to remanufacture that. So remember, these are heuristics. They are not laws of nature. Good. So if you're a MedTech company and you want to design your devices for more sustainability, just click the link in the description. Full disclaimer, it's a funnel. I want to book a call with you. I do not really care if you book a call with me over the funnel or not. I make these videos to provide value to you, but if you want help, there's just a video in there explaining how we could help you, and maybe you can book a call with me then. But yeah, if you liked the video and it provided value to you, I would love if you can comment, like, and subscribe. That helps me, of course, but also helps the YouTube algorithm to figure out what you like, and it will show you more content like this. So if you have another request for a video or you have a question, just ask them in the comments, because I will read all the comments and I will answer your questions and try to figure out how we can make your suggestions into new videos. So thank you very much for watching. I hope this is valuable for you and have a very good one.